Yeah, so moving on to the next session of the day, it is about rapidly deploying a quasi-static platform using serverless. Well, in this session, we are going to hear Arif Amirani talk about how to use serverless to deploy a quasi-static platform. Arif is the co-founder and CTO at Metro Guild. In the past, he has built large-scale systems and high-performance teams across 15 years of his career and worked in various enterprises and startups. Arif has won IAF Entrepreneur of the Year along with the Startup of the Year award in 2020. Let's gear up to hear from Arif on how to deploy a quasi-static platform using serverless.
Thank you so much, Dolly, for having me on here. It's wonderful to see so many people on a wonderful afternoon. I'll quickly share my screen and get started. All right. So before I begin, I just wanted to make sure that people understand that this is what I'm going to talk about is our experience when during COVID times we were tasked with building a platform to share information. And instead of going with a very traditional route, we sort of ventured into an area building an architecture that was not based on databases, but purely on serverless solutions that Amazon provided. Okay, a little bit about me. I run a startup, B2B startup based out of US. I've built architectures for over 15 years, and have been working with Amazon for over 10 years. So I have a pretty good handle on what Amazon provides, and that formed the basis of several decisions that I made going forward. Right. So what was the issue that we were solving, right? What was the challenge that we were given? So during the COVID period, what happened is that we basically were given, information was not available for people. And if you remember during the second wave, the information resided with very few people, and the number of people that needed that information were a lot. So we were working with an NGO, and they came up with a few requirements, and they said, okay, first you got to work with volunteers, right? So our entire project that we were supposed to build was to work with several volunteers, and these volunteers weren't very technically savvy, right? The other thing was that the focus was only sharing information. So there was a lot of emphasis on reading information, right? We also knew that this could get very large. We knew that this could go across the country, which it did. Also, it needed a lot. It had a lot of stakeholders, right? So the various stakeholders that we were involved with were, of course, people who needed the info. There were medical professionals. There were government agencies that were giving us this information. There were NGOs who were trying to also take this information and use it in different ways, right? We also did not have a lot of time to do this, because when the COVID pandemic hit, we had to get started and get this to the market very, very quickly, right? The last and the most important thing was that there was a requirement that you had to be an ease of data entry. And what that meant is that we couldn't really give any complicated UIs. We didn't even have the time to build complicated UIs to sort of make this, right? So these were the important needs that were there. Beyond that, there were technical requirements that were given to us. And by the way, this was only a couple of people starting it off. It wasn't a very large team, right? So the first thing that was there was we needed media support. That means we were, because we were giving out information to people, there was a lot of information that we had to also store. And that was not only just textual information, it was videos, images, podcasts, a lot of other things that could help people during this time of the pandemic. Another interesting requirement that we got was it had to be multilingual, right? And needed to have regional support, because during the pandemic, different regions faced the lash of the pandemic in different ways, right? So the information also differed from region to region, and because this entire system was not being built for technically savvy people who knew Twitter and Facebook, couldn't read English very well, we also had to do it for the masses, and therefore it had to be multilingual, right? And we ended up supporting around 8 languages by the end of the 8 weeks that we worked on it. Also, one interesting attribute of this entire system was that the data that we got from various sources was intermittent, And this is very, very crucial, right? Because this wasn't a ticker tape system. This wasn't a real-time system in any manner. This wasn't about stock trading or anything of that sort. So one of the crucial things that we kept in mind when we designed this architecture was that data can come, but in very short bursts. And there is also wasn't a requirement that the information had to be available on the UI at the same second. We could take 5-10 minutes, right up to 15 minutes to actually show this, update this data on the client side, right? And this is going to be very, very crucial as we talk more about it. We also needed to understand how this platform was going to get used, right? So analytics was very, very important. And the idea here was, because it was being used by the masses, we weren't really sure how they would adopt a platform which was never out there before, right? And of course, people are used to Facebook and Twitter, especially Facebook, even at the masses level, but we had to capture a lot of analytics. The other thing was that because we were trying to make this for people who don't live in urban areas, it was also meant for the rural areas. The idea was that they probably did not have really good devices, right? So the screen sizes varied, the network and the bandwidth requirement varied. We even had to go down to 2G and 3G to sort of say, okay, we can't expect Wi-Fi usage only, right? Or Wi-Fi availability only. And when we were discussing about all this in the discovery phase, the other need that came up technically was that, hey, you know what? When you are going to collect so much data, you got to make sure that you share it to other parties as well, right? So data needed to be accessible via an API to third party, right? And this third party could be other NGOs, it could be the government themselves, it could be other small crowdsourced groups that were trying to also use this data. And at the bottom line was, because this was a self effort in the beginning, which kind of got adopted later, cost effectiveness was extremely important for us. We couldn't really spend a whole bit of money on this and take a long time to build this. We needed to get it out quick. We needed to get out absolutely working on the first go, and we had to make it cost effective, right? So when you see all these requirements, and if you have a good background on building architectures, you've done this before in earlier companies, what's the right answer to an architecture like this, right? The most of the times, the first answer and almost the right answer is that it's a 3-tier architecture. You've got your load balancer in front, you can scale your EC2 instances, you've got a hardened and a time battle tested database like MySQL or Postgres that's going to handle all your data reads and writes. Why don't we just do that, right? So of course, this was one of the things that we wanted to do, but because we did not really we had the cost thing in mind, and we did not know how much this would scale. And also one other thing was, this was because we were giving information during the COVID period, and high availability was extremely important. And also team size being small, we thought of said, okay, this is going to take a lot of heavy lifting. This will require a lot more volunteers to do it, and this may not be the right answer, right? So what are the other options that we chose, right? There were a few other ways that we could have solved this problem. Of course, 3-tier architecture, we sort of threw that out. We said we don't want to do that. The other option was low-code and no-code platforms, right? They were pretty prolific. They are, getting very, very stable. They are getting very mature. And in fact, a lot of groups during the pandemic time actually ended up using low-code platforms to quickly be able to share data. Our challenge here was that because we had a sense that this could grow big, low-code platforms, when initially they have free tiers, but once you have a lot of volume coming in, a lot of traffic coming in, the cost does grow exponentially, right? So we didn't have experience with low-code, no-code at that time, so we sort of discarded that idea as well. The other option that we sort of looked at is, how about an if this then that kind of a model, right? Where data could be hosted somewhere. As soon as the data gets updated, our internal systems could be notified, and we use a standard website builder to build the interface. That also, again, because we didn't have experience with that, also there was the cost problem with it. We sort of said, okay, that may not actually work for us. and of course, you got to put WordPress in there, but we didn't have the kind of experience that we wanted to make sure that the success of this platform. So we discarded WordPress as well. I'm going to quickly show you what the solution looked like before I get into the architecture. At the end of the day, based on the decisions that we've made, based on the solution that we provided, and of course, a major impact or a major focus was on the UI, because the usage of it was very, very important. It wasn't an academic exercise that we were doing. We actually wanted adoption of this. And we are happy to say it's a bittersweet thing, because we are happy that it got adopted, but we hope that it was never used in the way it was, right? With millions of users trying to use it during the pandemic times. But we, at the end of about 8 weeks, we ended up covering about 70% of the country, right? We provided information to almost major states and all tier 1 cities, right? And we collected data from more than 100 plus sources using that solution. And like I said, we also went into 8 to 9 languages, and we covered a huge ground. In fact, getting government support at one time as well, right? And what is it that we saw? So let's talk a little bit about what we ended up seeing as a outcome of the decisions that we made, right? So as you see that we went from 0 to about 4-5 million requests, serving requests within a few days. And a 3-tier architecture or any other architecture, we believe, given our experience, wouldn't have scaled so much, right? And given the criticality of the platform, given how critical it was, right? If you're looking for a critical resource, if you're looking for a bed or plasma, and if your UI is not able to serve it, right? Your UI is down for some reason, or it's running slowly, you are not actually solving the problem of the visitor, right? You can't expect them to keep retrying or refreshing the page while they are under duress, correct? So given all of that load that we received in a matter of days, our error rate, especially in the first spike that you see, which by the way is just 1.4% of our total request, that was due to an issue on the client side. We have had 0 errors on the server side. And that is because there were really no moving parts, right? There was nothing that could actually go down or have a downtime or needed maintenance because of the combination of choices of the solutions provided by Amazon, which is what we use, right? So this was really, really great to see the volume of traffic we got and literally having a 0 error rate over a period of 4 to 8 weeks, right? Now, of course, the flip side of having resiliency and having such uptime is that did we actually end up spending money? We didn't, right? In most of the cases, we actually were under the free tier of Amazon. In fact, Amazon helped us a little bit as well. But we were under the free tier for most of our backend systems. The only thing that we ended up paying money for was data transfer. And that's something obviously is a function of the volume that we got. We couldn't reduce that. We ended up adding a lot of caching and a few other things. But and we'll talk about those aspects as we go along. But data transfer was the only thing that we ended up spending money on, right? Everything else was pretty much under the free tier. The text track that you see was an experiment that we did of getting data from PDFs because a lot of sources were PDF sources as well, and Amazon helped there too, right, to get information from all of that. So this was just a really good success story as far as cost optimization also goes for us. So what did we actually do? Having given you the background, having given you the outcome that we achieved, how did we actually go about doing it? So one of the first things that we did is that instead of using a real database, we actually created a database kind of a system by using S3 as our data store, right? That's why we call it as a quasi-static, which is, it looks like a static database, but it had some updates coming to it. Now, remember, why did we do that, right? So the most important thing was that data came to us intermittently. And we had a ratio of, I would say, 1:100,000 when it comes to writes versus reads, right? So if a write came in, there'd be a million reads for that same data, but it would be a single write for us, correct? So at the top of the architecture, you'll see the origin databases, right? These were the data sources that we collected from. These were different kind of databases, and we'll talk about them a little bit. But it's spanned from your MySQL sources to S3 to Airtable to Google Sheets as well, right? Everything we could be considered our original database. This data was being pulled through a fleet of Lambda functions, right? So we ended up using Lambda for polling these databases over an interval, and everything was written in Python. We used various libraries to parse, transform, normalize, do all sorts of things, and then sort of convert them into basic JSON files that were readable by the UI. And we would just dump them into S3. Right, and S3 being highly available, we never had a doubt that S3 would be not available. So we didn't even have cross-region replication or anything of that sort. We focused it in India. Everything was based on AP South 1, and that's where we kept it. Right. So the data comes into S3, and if you notice this block, which is the CloudFront, that's where was serving data directly by the information portal, and the information portal was a React application that actually just made a call to the backend using your standard CloudFront URL, pulled the JSON and rendered the information. Correct. The other side of it, however, was also that, like I earlier mentioned, that we had analytics as a use case. So analytics, obviously, you would assume that when you're writing analytics, you wouldn't write it to S3 as data points. That doesn't make sense when you want to read it from a cost efficiency perspective, and that's right. The right path that we had coming in from the clients actually went through an API gateway and hit a DynamoDB. And analytics here were sort of rolled up on the client side and then pushed to DynamoDB, right? So we were not sending a whole bunch of data. We weren't sending, open. We were sending a smallest subset of analytics, right? Which hospitals are people visiting? What kind of filters are they applying? If they're watching a video or if they're listening to an audio, then which one is the most heavily used one, right? So that's what we looked at, and data went from the API gateway directly into Dynamo. There weren't any EC2 instances or anything of that sort, right? There's obviously a Lambda function that was reading it. And then we'll go to the API clients as well we go it. Now, the other side, which is the right-hand side of it, when we had so much data being collected from these origin databases and the analytics, how did we sort of process that, right? And again, this was completely done without running a single EC2 instance or anything of that sort, right? We built an aggregator Lambda layer, which was again scheduled Lambdas that were polling information from DynamoDB and the S3 sources, which is the hospital data or the patient data that we were storing as JSON files, and then aggregating them and putting them on a reporting S3 bucket. This allowed us to work at scale. We never hit the 15-minute limit of Lambda as well. We had a fleet of aggregator Lambdas that actually, split up data into smaller chunks and then sort of consumed it, right? And the content analytics portal, which was consumed by the government stakeholders as well as our own systems, that was a single shot. We went through CloudFront, read the S3 and pulled it back out, right? So throughout this entire architecture, if you notice, we did not have a single database. And again, the why we could do this is because of the eventual database update model that we have, right? And we'll talk about it a little bit later as well. So breaking it down, right? How did these individual pieces look like? You will notice that the origin databases were anything. They could be anything. As long as we could programmatically read them, we actually worked with anything. So we had a volunteer force that was using Airtable as their main database to maintain a list of hospital availability, medicine availability, and all of that, right? So we got an API for that, and we pulled data from there. Our own internal systems that we gave to various stakeholders, like hospitals who were giving us data, we actually ended up giving them a Google Sheet. So they would fill up a Google Sheet and we'd read that using Google API, right? We also had MySQL sources, we had S3 sources, we had other sources, right? So that all formed the origin database, and it was very easy to sort of add anyone at any given point of time. The pull Lambda servers, that fleet really grew a lot. At the end of, I think, 4 weeks, we had about 50 or 60 core Lambda scrapers that would go to various sources, right from government websites to these other origin databases and all of that, and pull data from there, right? But their job was very simple. All they did was they would pull data, scrape it, normalize it, and convert it into a JSON and dump it into an S3. That was the entire path that we had, right? Which was just brilliant because it kept things very, very simple for us, right? As far as reading goes, this was a single page application that actually read data from an S3 as a JSON and just worked. We consciously decided to not do any filtering on the server side. So any sort of filtering, sorting, searching, everything was done on the client end, right? All that code was written on the client end. The server would only give a JSON, that's it, right? That also gave us a lot of ability to experiment because we didn't have to change the database, look at migrations or anything of that sort, right? We could really move very, very fast. So that was really brilliant for us, given how small we were. From the API side, right? The API clients would directly communicate with the API gateway, and API gateway would talk to S3 and give data to third party, because whatever data we had on the website, that was the exact same data that was exposed to the API clients. We didn't sort of have any other view of that data, right? And like I said, the events analytics that came through the API gateway and wrote to DynamoDB, and that's it. We've spoken extensively around the analytics part, so that remains the same. But again, no moving parts out there that could fail, or there wasn't a single point of failure for us at any given point of time. Let's talk a little bit about the API gateway, because this was very, very interesting for us. Why did we choose to not give access to the JSON CloudFront URL that the website was using directly to our partners, right? Why didn't we do that? There's a reason behind it. Because initially, when we started doing that, people used our S3 and CloudFront backend as their backend, right? So we ended up spending a bit of money because people just made their UIs and mobile apps and different single page applications. They only wrote the UI and they would simply bank on our backend, and that would increase our cost. So then what we started doing is that we started creating API keys. We had that basic authentication in place. And every time a third party wanted data from us, we would point them to this API gateway endpoint. Again, no plumbing was needed because we didn't have to build anything. Everything came out of the box with API gateway. API gateway also supports usage plans, right? So we could really rate limit our third party people as well, saying, look, if the data is going to come every 15 minutes, you cannot really hit our API gateway, 100 times a second. You got to slow down as well, and you can cache the data on your end, right? So the well-behaved third-party folks, they actually fetch data from us once every 10 minutes or 5 minutes and cache it on their end while serving to their clients, right? One interesting thing that really was a delightful thing was API gateway directly connects with S3. So nobody needed to build a Lambda or any other intermediary while fetching data from S3. So on the top right-hand side, if you see, this API gateway endpoint, which does a GET, is directly connected to S3, right? So again, no plumbing needed, nothing that we needed to do, and immediately started working. Conclusions on our side after doing all of this, how we fared internally and how we did our retrospective. When we did our retrospective, we only spent about a month and a half actually building the entire platform, right? And out of which, the first 15 days were actually spent on only discovery. That where will we get data from? How much should we sort of think about? What's the scale that we should think about? Working with government and all of that. The actual development time on the product, on the platform, was a month, out of which I think we spent about 20 days only on the UI, right? So the decision of not raising an infrastructure or using a standard architecture really saved us a lot of time. We reached about 2 million visitors with zero downtime, which was really amazing. And all services were under free tier. So we didn't even have to go to people and raise CSR funds or, had some continuity issues there as well. We could self-fund ourselves for the majority of the time, right? The most we paid was for the data transfer. nothing else. And like I said, zero downtime on anything, right? Again, because we didn't have a database in our critical path. So any of the read paths, right? Because we were sharing information, the most critical path for us was whether we could serve data to our users, right? DynamoDB wasn't in that path. DynamoDB was all about analytics and API clients, maybe in some cases or something like that, right? So even if we ran out of the limit on DynamoDB, or we did not scale very well, or whatever, or made some mistakes over there, DynamoDB never really caused any issues for us. We also, in the beginning, we were deploying using our own clients, our own laptops, but we eventually moved to code pipeline because the number of scrapers and Lambda fleet that we had was really scaled very, very large. So code pipeline really helped us a lot, right? You could simply push in code, or it went through a bunch of tests, and then all those fleets would go to production automatically. So what that did for us is that we really did not need a DevOps person, right? We did not really need anybody else apart from the backend person and the front end UI person contributing, right? So that was really great, right, for us. What are the learnings that we got? First is complex is not always good. Typically when we spoke to people about this architecture, people would say, hey, you need a database, you need this, you need that, you need different components of an architecture to deploy something like this. But really, first principles thinking, taking it slowly, taking it sort of, okay, what are we trying to solve, really helped us get to the simplicity of the entire architecture, right? The second thing we learned was, caching killed 10% of our users. And what I mean by that is because of a misconfiguration and because everything was on the client side, because of a misconfiguration where we set up a higher caching, these 10% of the users never got an update for about 7 days, right? So we sort of set an expiry on our static resources very high, and the clients we don't control, right? So that's the problem when you don't have things on the server side, a lot of things on the server side. But if you're fully dependent on the client to house most of the business logic, a simple thing like caching will cause problems for you, right? And it did for us. The next point is that would we actually use this for any of our future projects? Probably not, right? This was a very, very niche and very well thought of use case, right? Where you're writing once and reading, a million times. If we had several write paths, like say, for example, if our users were sending more data beyond analytics, which was okay to lose in some cases, we would probably go with a traditional database architecture or some other architecture, right? This was a very, very concise use case for us, right? The other way that I look at it, and this is my personal opinion, my team would probably have different opinions around it. I actually think that this was a DevOps success story. And what I mean by that is that the UI was hard, but it was a solved problem. The backend piece of scraping, normalizing, working with data, again, a solved problem, right? You really don't need to think about it, or it's very straightforward, right? If you know what you're doing. But the DevOps, the decisions that we made on the architecture, how we host it, how we deploy it, I think Amazon as a partner really made it a DevOps success story. Correct? Without that infrastructure holding us up in the first few days, I think if we didn't go with the choices that we made and the partner that we chose, we would be spending the next 15 days just solving architecture problems. We would be just solving, reliability problems. But because all these, serverless systems, you've got a reliable key value store, document store, all of that being available, a lot of the hard work and uncertainty was thrown out of the window, and we could only focus on the people. We could only focus on the business problem, right? So that was one learning that we got, right? Again, one important thing that we got asked quite a bit was, how did you monitor this system? Because you had a lot of people using it, you had a lot of data that you were ingesting, you were sending data all over the place. We didn't end up, again, working with a lot of monitoring systems because there was nothing to monitor except for the business logic, right? If anything went wrong, yes, we would know about it immediately through logs and all, but basic CloudWatch monitoring with, how the load is, if there are any error rates that are happening, maybe something is getting stuck. That was the only thing. Again, would I do this in production? Probably not. In a more business environment, in a production environment, I would probably have a lot more hardcore monitoring being built and tooling being built around it, right? So that's pretty much it on our side. One thing that I forgot to mention is that the whole system was actually built using infrastructure as code. So we did not log in into the console, we did not use CLIs, we didn't do anything of that sort. Everything was built around CDK. So everything was codified. That also helped us to bring volunteers who just came in and knew that, okay, if I make these changes and run CDK deploy, it's going to absolutely work, right? The whole thing was replicable. In fact, as we went from one state to the other and we grew from one city to the other, because everything was codified, it was just a matter of making a few changes in code and an entire new stack could come up without us having to be uncertain whether it would work or not, right? So infrastructure as code also really helped us quite a bit over there. Again, thank you so much for listening. I'm open to questions or any thoughts people may have.
Thank you, Arif, for the enlightening and wonderful talk. It was very interesting and a well-explained session the audience had. So now the stage is open for Q&A, and let's see if the audience has any questions. So we have a question from Charles. Is Terraform or CFT better for API GW automation?
So I would say that in my experience, we actually went with CDK, but and CDK worked very well. You could do that. Terraform, however, is much more agnostic to vendors, and I think it's a little more mature than CDK or using SAM CLI or something else like that. But I would definitely look at your own experience of how you can do this and then sort of evaluate these cloud formation technologies.
Okay. Moving ahead to the next question. How do we replicate exact BCM scenario in AWS?
In our case, actually by BCM, I just want to make sure, are you talking business continuity, Bhakti, out here? I think we can come back to this question when we have a little bit more context.
Okay.
Yeah.
Yeah. So moving on to the next question. How we unite the different vendor-related services under AWS?
Actually, Amazon does an amazing thing of being deeply integrated with everything, right? I mean, a testament to that fact is if you look at Step Functions, which was recently updated, now they've got 200 services under Step Functions, right? So Amazon actually strives a lot to make these services cross-compatible. And in our case, that's the exact thing that worked for us, right? Because like say the API gateway example. API gateway was deeply integrated with S3, which we did not even know about. We thought we'd have to probably write a Lambda function to pull data from S3 and then just pass it through to the user. But you just got to investigate a little bit, and I'm guessing that everything is perfectly available and cross works out of the box.
Okay, thank you for that answer. And we have another question. How to decide when to use DynamoDB or SQLDB while creating infra?
It's again, both of them have their own pros and cons, and they also have different characteristics, right? They have different properties. DynamoDB is extremely scalable, resilient. globally available service now, given that it has cross replication and you have global tables as well. So it really depends on your use case. DynamoDB will have its own issues like indexing or things like that, versus a standard SQL database is much more mature around those kind of use cases. But there is no single answer for that, right? You really have to look at what you're trying to do, evaluate both of these solutions, and then pick one, right? That's how I would look at it.
Okay. And moving to the previous question that was asked, how do we replicate exact BCM scenario in AWS? By BCM, he means BCM is business continuity management.
Right.
Suppose I have a DB. If primary DB crashes, how do I fail over to BCP or even overall application?
So business continuity is a whole topic on its own, right? It might take an hour to talk about it, but so in general, there are various ways of failover. There's various ways of ensuring availability and continuity, right from warm standby to pilot light to other things. It really depends on your use case, right? And every database, especially if you look at the Amazon services that are there, they are highly reliable. It's how you configure them, right? If you want cross-region replication, then you might have some ways to do that. If you want active, you might actually be able to look at that as well. Like Aurora has different characteristics when it comes to being available, and when the master fails, how does the slave takes over. So again, it really varies from service to service, but there are quite a few models around that.
Okay, thank you so much. It was quite perceptive and a well-explained answer. Thank you so much, Arif, for this wonderful session.
Thank you.
Once again, thank you, Arif, and thank you, Dolly, for that. So let's move on to the next session. Build. Go, build. There is no compression algorithm for experience. Def and test are the most important workloads. Dance like nobody's watching. 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 Dance like nobody's watching.